and a few words about ROGII itself, who we are, what we are doing. And our company was established in the back in 2013 in Houston. For now, we have more than 200 employers. It's software engineer, geoscientists, mathematicians, geologists, drilling engineers, and nowadays we are presented in more than 10 countries in the world. It's Canada, North America, Mexico, Argentina, Colombia, Norway, Germany, Middle East, China, Kazakhstan. And the goal of our company is to simplify the process of geosteering, workflow. For this goal, we have a few applications. And today we are going to speak about our main application, our first application we developed. It's StarSteer. It's software for geosteering. So before we start speaking about software itself, I would like to ask you what kind of experience do you have with geosteering, and do you understand the process of geosteering? If you have some experience, just type a sign plus in the chat. If you don't have, type a minus. And if all of us understand that concept of geosteering, we can skip these slides. How do you think, Serge?
Well, the guys on the call today are pretty experienced, but not everyone. You can go pretty fast, I think, because everyone.
Okay, yeah. I will explain a little bit. Let's imagine that we discovered new field, and we would like to drill the first horizontal well in the field, and we have only few exploration wells, and we have seismic data, and we build our model based on this data, and we assume that we will have in real time, we will have this formation behavior, almost sub-horizontal target formation. And we planned accordingly our trajectory, and we are happy and ready to drill the well. But reality can be different, and our planned trajectory can be out of our reserve because of some geological changes, which we did not expect on the pre-job stage. So geosteering help us to keep trajectory inside the target and to increase the coverage of the target zone, of the sweet zone. So if we continue drilling along geometrically along the planned trajectory, we will miss the target. We will cross it and exit from the bottom and place our trajectory below our sweet zone. But using geosteering, we can react to some geological changes immediately and can return to the target faster and can increase reservoir coverage, and as a result, we can increase production and earn more money. So it's the goal of geosteering. It's to keep trajectory inside the target and to increase the reservoir coverage. And what is the methods of geosteering? We have 3 levels of geosteering. The first level, it's simple model compare update. It's just correlation between logs, but this correlation can be done by different approaches. So in StarSteer we have 2 approaches to correlate the data. It's model-based approach and stratigraphical based approach. We will discuss later in more details. And level 2, it's image log interpretation. So when we drill the well, we are rotating our BHA and we can get a signal from sectors around the wellbore. And by combining these signals, we can create this kind of image which can be interpreted. And by interpretation of this image, we can get information about apparent dip and build our interpretation based on these apparent dips and this interpretation. So it's another method. It's more high-tech method than simple correlation. And we need to have, during real time, we need to have azimuthal tools to provide, to acquire this data in real time. And the last, not the least, level of geosteering, it's only one method which allows us to see boundaries on the distance. So it's different resistivity inversions. Resistivity is the deepest method we can use in real time, and by using resistivity we can detect boundaries before we cross it. So these two levels, these two methods we use when we cross some boundaries. We can interpret this data only when we cross some boundaries, but with resistivity inversion we can see these boundaries on the distance, and we can keep trajectory inside our target without exiting. Yeah, that's very short overview about what is geosteering and what we are going to speak, what we are going to cover during this presentation with StarSteer implementation. And let's continue and speak about StarSteer itself. So I would like to start with this slide, which explains what kind of data can be used in StarSteer. We can use all the data, LWD, MWD logs. We can use top sets from type well, from current well, like a plant top sets. And we can use grids, 2D grids, maps, which can be used to get information about structure behavior. And we can use 3D seismic data and 3D geo models. It's very helpful if you have some lateral changes and you expect to have some fault. You can rely on this data to get this information and to react properly. And all of this data can be uploaded to StarSteer 3 ways. It's bulk upload. So you can just drag and drop the data to StarSteer. It's very quick, it's very easy, and you can set up your project just I don't know, you can spend only 5 minutes to set up a project. And we have PTRL plugin. If you are using PTRL for 01 modeling, you can you can use PTRL plugin to transfer data to StarSteer directly. So you just need to choose what you want to send to StarSteer and push the button, and immediately in StarSteer you will see this data. And we have XML streaming. So if you have XML server and you have credential, you can stream a data in real time to StarSteer, or you can stream like memory data from the previous well directly to StarSteer. Speaking about level 1, so we discussed with you 3 levels of geosteering. Let's start with level 1, the simplest one, but not less important. And here we have explanation how model-based method geosteering works. So for model-based method, we have type well log. We have type well somewhere close to our current drilling well. And this type well has some logs. For instance, in this example, we have gamma ray. And this gamma ray, we propagate along the trajectory by creating interpretation. So we separate the logs by small layers, and we assign the values of gamma ray in each layer. And after that, we create this interpretation and propagate these properties along our current trajectory. So in the results, we receive this interpretation, and we receive a response of gamma ray log on when we cross these layers by our actual trajectory. So by changing this interpretation, we can see immediate response of the log on horizontal track, synthetic log on horizontal track. And you can see in this case that we have one good match here when we have almost sub-horizontal behavior of our formation, and we have good match here when we have degree like 92 degree up in training direction. And yeah, it's good method, but it's not so precise when we have some lateral changes, and we have some like we have, for instance, in this example, we have a few different ways of correlation, few different cases when we have a very good correlation. So it's questionable what is the right position of our boundaries, and but it's very quick method. You can create your model very quickly and start correlating. And we have another method in StarSteer. It's called Strat-based method, and in this method we use our data from type file in vertical track, in TVT scale, true vertical thickness scale. True vertical thickness scale takes into account your trajectory, your inclination, and keeps your thicknesses of your layers. So here we don't correlate data in horizontal track. Using this method, we correlate data in vertical track, real data from type file with actual data, real data from lateral drilling. And let's see how it works. We have a log. We can see a very good correlation here. And after some point, okay, I need to stop it. Let me switch it off and stop at some point, somewhere here. And you can see that the blue curve represents the log from type well, and the red one is the log from actual well. And you can notice that the blue one is smoother and lazier than red one. Why it's happened? Because of vertical well has less vertical resolution. It's the same tools, but we are crossing the formation vertically, and we are limited by vertical resolution of the tool. But when we have some angle between our trajectory and our interpretation, we artificially increase our vertical resolution of our logs. So when we cross the formation on some angle, we can detect layers with smaller thicknesses. And here's the result that we have actual curves with more details than curve from type file. And when we start drilling, we reach the deepest point of our trajectory. We've got this data, and we can, when we drill back up, back to the same formation, we started drilling up. We started to receive the same logs. We were crossing the same formation, and we can correlate this log on itself. And here, when we reach this point, you can see these small layers. Okay, let me go to project directly. I think it will be easier to explain on the project. Here we have the same project, and you can see these logs on the vertical track. So the black one is from type well log, and the blue one with the red part, it's from real time. So when we reached this deepest point and started drilling up direction, let me come back. Yeah, I mean artificial because of I think we need to explain somewhere on the. I have a paint can draw.
It's not really artificial, is it? It really is. If you think of it, when you drill a vertical well, you collect a sample on your tool, on your logging tool, possibly every 6 inches, every 15 centimeters. Yeah, you take a sample. You take another sample, you take another sample vertically. But when you go to horizontal, and maybe you keep the same collection of information, you take it every 6 inches horizontally. But if you're in a zone and you're going in a 1 meter interval, up and down through one interval for 5 kilometers, you could possibly sample that interval tens of thousands of times. So you get a much higher resolution vertically when you've sampled that maybe 10,000 times. Is that clear? It's hard to describe. I usually use the floor to show people how they can.
Yeah. I drew some picture.
Go for it. Go for it,
On
Daniel.
the pane. So here we have a vertical well, and we have our transmitter and receiver. And when we are getting the data, we have this like this zone where we get the data. So we cannot separate. In this case, we have vertical resolution indicates by the distance between this transmitter and receiver. So we can separate the layers in this area only on the distance, like, I don't know, 1 and 10 centimeters, for instance. And if we have layers with thickness less than 10 centimeters, we cannot see this reaction on the logs because of our limited vertical resolution. But when we cross the same layers with some angle, and we have the same distance between transmitter and receiver, now I can get a survey in this layer, and I can get a survey in this layer. So when I increase my incidence angle decrease my incidence angle between interpretation and trajectory, I can say that I artificially increase my vertical resolution. Distance between transmitter and receiver keeps the same, but because of I have some angle between interpretation and between layers and trajectory, I can get surveys from smaller layers, from the layers with less thickness. Okay. Is it understandable, or we need to repeat? Okay. Let's continue. Yeah, and speaking about Strat-based method, so we have, you see, we have more details on the real-time curve, and these small layers can be correlated too. So when we reached the deepest point and started drilling opposite direction and crossing the same formation again, we receive this part of data, and I can see that these small layers can be correlating on itself. So here I don't have already correlation with my, okay, let me switch off the log from type well. Okay, without log of type well, I can correlate log on itself. So I don't need, when I reach the deepest point, I don't need to use type well log for correlation. I can use just only my current actual log. And to find the apparent dip, I need to find the match between these curves. So here I have very good match. I have some lateral changes for sure between these zones, like the thickness and the value of gamma ray in these small layers is not the same as I crossed before. But anyway, I can see the same trends, the same patterns. And to continue correlation, I lost the correlation somewhere here. I would like to continue it. I just need to put another segment and to move all of this part down. So you can see I started to see correlation in this part, and I can observe the same layers here. And I want to continue correlation here to find a good match. You see, when I move it, I see very clear that I have the same curves behavior. So it's the same formation, it's the same layers, the same details, which can be correlated. But if I switch on my type well log, I don't see these layers here because it's smoother and lazier than my actual curve. So it's a benefits of Strat-based method. We can make a more precise correlation, and we can use our curve for correlation on itself. So we just can exclude. Mm-hmm.
One more thing, Daniel. Of course, StarSteer, it gives you all the dips of the bed dips are right there, aren't they? I mean, it's hard to read on screen, but you get each of the sections, you get the bed dip, and they're not changing much. It looks like they're changing a lot, but it's because of this vertical exaggeration. But tell us what the bed dip changes are there across the sections. Is it?
Yeah, this segment show us 90 degree, almost 90 degree, and this segment 91.4, and this one again almost 90, 89.9.
So there you go. You see a very small change in dip, and you get an almost perfect correlation with the well. So that's the beauty of this software. You're staying almost within, you know, the plus or minus resolution of your geo model, potentially of any kind of grids that you have in the area, but within, you know, a fraction of a degree change, and it puts the well in the right spot. So that's the exciting piece of StarSteer, where you can actually place the well exactly in the geology, because the drillers, of course, can tell you exactly where they are, X, Y, Z, but as a geoscientist, you want to know exactly where you are in the stratigraphy as well. So that's the power of StarSteer right here. If you don't get anything else from this webinar, please remember that you can correlate a horizontal well all the way along and place it exactly in your geology. Sorry, Daniel.
Yeah, and another benefits of Strat-based method is that, for instance, if you have your type well very far away from your current drilling, you cannot rely on this data, because probably it should be huge lateral change, etc. But using Strat-based method, you are correlating with the data you crossed like maybe 200 meters before, or maybe less. So it's always closest point to your current correlation, closest data point. So yeah, and additionally about StarSteer, what we have here, we have model-based method, Strat-based method, and all of these methods can be used by some kind of algorithm to create interpretation. So in StarSteer, we have artificial intelligence, which help us to create interpretation and help us to geosteer as well. And it's like a second opinion. You can use machine to provide you some alternative interpretation to scenario. I would like to show it here on the example. I have I have very good correlation. I did it by myself. You see, let me switch it off. Yeah, I did it by myself, and I'm very happy with this correlation. Everything correlated almost perfectly. There is some mismatch, but anyway, it's my human correlation. And I would like to let my artificial intelligence to create its own interpretation, and I would like to compare interpretation of machine with my interpretation. So let's do it. I have another interpretation. It's empty. Here I have only one segment with 90 degree. And if I go to after steer, we have additional mode which called after steer. And I choose the log from type well. It will be gamma ray log, and the log from real-time gamma ray, and a log from type well gamma ray as well. And here I just need to put regional deep. Okay, let's keep 90, and deep range. Yeah, let's give some floor to algorithm to find out the deep. So I will keep 5, and I just need to click the button start. So calculation is started. You can see here in the argument that calculation is going on. And let's wait, it's just 40% till the end. And in the result, I will receive the interpretation done by some artificial intelligence, which can be used in real time as a second opinion, and can bring you new ideas where you are, and probably can help you to avoid some mistakes. So it's interpretation done by algorithm. So I did not do anything by myself. I just push the button and let algorithm do this correlation, and you can see that it's almost perfect. We can see some mismatch in this part, but anyway, trends and patterns I like a lot. So if I compare this interpretation done by AI with my manual interpretation, I can see some differences, like in this part, in this one, but it's not so huge. So we can, in real time, anyway, we can rely on AutoSteer, but in simple formation. If we have some heterogeneous formation with a lot of lateral changes, AutoSteer will not help you. But in this example, where we have good correlation and AutoSteer can show you some proper trends.
This is great, Daniel. This is exciting. When we do this for ourselves, often we're stuck with one or two logs or one way to think about the correlation. For instance, the gamma ray only. But when you're using this AutoSteer, this artificial intelligence, I think it can use all of the logs. Is that correct? It's more than just one log.
Yeah, for now we can use only one log, but you can run different interpretation. For instance, you can run one interpretation with using gamma ray log, another one with resistivity, another one with density, and you can combine this interpretation and find out what is your proper interpretation, what is the best match.
Yeah, so we're not used to sometimes looking at as deeply into the density or the resistivity logs. So we get focused on one, but if you run the AutoSteer, the artificial intelligence on the other logs and bring them in, it can give you a true independent view. So this is an exciting part of the software where it doesn't get rid of us completely. Don't worry, ops geologists and well site geologists, you're still needed. However, it's nice to have a second opinion, and we were certainly impressed with it when we ran it here on our projects here. It shows a second opinion, gets you thinking.
Yeah, right. Yeah, sometimes because geosteering is 24/7 job, and you need to be focused all time. So sometimes you're tired during the night shift, and it's good way to check your interpretation to run AutoSteer. And if you have some mismatch between your interpretation and interpretation of AI, you can use it to adjust your own interpretation. So yeah, it's a good tool. Yeah, interesting story about AutoSteer, that we have a team in Argentina. They are working on the conventional project, and we drilled one well without people involvement. So we drilled the well only with AutoSteer, and engineer just sent the recommendation to the rig provided by AutoSteer. So it was nice experience, but anyway, we always say that we need to use engineers' experience to check this algorithm. You cannot rely completely on some artificial intelligence. Do you have any questions maybe about Strat-based method, model-based method, how AutoSteer works?
No, I don't think there's any questions at this time, other than when you buy a license of StarSteer, does it come with all of the modules, or is there different levels of StarSteer?
Okay, in basic, we have all the methods, this AutoSteer, but if you are thinking about to use inversion, you need to buy another license. So we have separate license for inversion.
Understood. That's your new inversion for resistivity, and it's actually one of the only ones on the market today. So it's quite a powerful tool to compare all the vendors, but also to understand whether you need to acquire this data or not, whether conventional resistivity is fine, or you need the full-on ecoscopes, stethoscopes, those kind of things. Okay, so understood. So those are the two levels at the moment, are the base version or the resistivity modeling version.
Yeah, additionally, we have a cloud platform. We will speak about it later. very shortly, but additionally we have a license for cloud too. So it's very helpful collaborative platform. You can work on one project simultaneously, and yeah, it's very powerful.
So there was one question. Can you detect fluid boundaries in real-time operation? So that would be your resistivity modeling, wouldn't it? You would.
Yeah, right. Only resistivity can detect if fluid on the distance, so we cannot detect it by gamma ray or density porosity. Okay, density porosity can detect it by when you cross it already, but if you want to avoid to cross some fluid contacts, you need to use resistivity. Only resistivity can help to avoid it, to avoid crossing it. Yeah, let's continue.
And one more question, I guess, with respect to the chance of success. Thank you, Cindy, for the questions. What would be the, I guess, would be in zone, like the real success of the software is how much do you stay in zone with, you know, the actual versus planned, or I guess the success rate of a well is can you stay in the zone with the software? And I'd say the chances are pretty high.
Yeah, chances pretty high. It's very difficult to like calculate the certain percent, but yeah, StarSteer can help you to reach them best.
Yeah, I would say based on the repeat users and how they reduce the complexity of their bottom hole assemblies, I would say that, you know, the success rate is extremely high, and also the fact that they keep using the software and they reduce how much they put it down hole as far as the tools. The tools get simpler and simpler because they don't collect the information. They're leveraging the offset data instead. So yeah, I'd say the success rate's quite high.
Yeah, geosteering includes not only like software. Geosteering includes experience of engineers, collaboration between different assets and departments, collaboration with drilling operations, with drilling center, and etc. etc. So it's a lot of things which influence to the result. So we can say only about StarSteer that StarSteer is only if you cannot reach your desired like reservoir coverage with StarSteer, you don't have any other software to do the same. So for instance, here we have a Strat-based method and artificial intelligence, which can help you to drill the well. And I did not see any auto steer from others software providers. So yeah, let's continue. All of this model-based method and Strat-based method can be used not only with one type well log, it can be used with more type wells. So if you drill the well, sometimes you have some lateral changes and you need to switch your interpretation to another well. So here is an example from Venezuela. We have one type well 1 and type well 2. Type well 1 is closer to the wellhead of our current well, and type well 2 is closer to TD of our well. And we started drilling and we crossed our top and we are inside our target, and correlation was perfect. You can see that everything will match perfectly, and at some point here on the depth 4,600 we hit some zone with high gamma ray. So if we rely on type well 1 only, we can say that we hit the top, and we can correlate we can make our correlation based on information only from the type well 1, and we can have like deep in down formation. But when we find out that we have type well 2 and we see that we have the same increasing of gamma ray at the center of our target formation, we started to correlate on this type well 2, we switched our type well to another one. So here we continue drilling based on the data from type well 2, and you can see the correlation again. Correlation started to be perfect, and using 2 type wells, right now we are sure about that we have a lanes inside our formation, shale lanes in the center of our formation, and we can detect it, and we can place our well correctly inside the target, avoiding crossing these layers. So it's the benefits of using multi-type well geosteering, and in StarSteer you can use as many wells as you want. So you can correlate simultaneously for 10 wells, for 5 wells, for 2, and yeah, it's very flexible. And another level of geosteering is image interpretation. Regarding image interpretation, we have very simple tool how to interpret image. You don't need to go to another window to interpret it. You can visualize it at the same window on curtain section, and you can visualize it on the horizontal track, and you can interpret it here. So when you interpret an image, you can see immediately these sticks, which represents apparent dip of your sinusoid. And additionally, in StarSteer, it's possible to visualize the image along the trajectory as interpretation, and not interpretation, as an image with visualization of boundary position. You see, this is the heat map with red color and blue color. You can see the position of these boundaries. So we have a stick which represents interpretation of image, and we have image by itself, which represents behavior of my boundaries. And yeah, this is about images. Go further, and additionally we have resistivity part. So right now we came to the last level, level 3, which allow us to detect boundaries on the distance. And the first method here is deterministic inversion. This inversion can be used with bulk resistivity only. So you don't need to run any fancy expensive tool to get information about boundary position on the distance. You can use the same common BHA with bulk resistivity. This method is using separation between curves with different depths of investigation to understand the distance to the boundary. So the separation between curves indicates the boundary position, and by running this algorithm, you can predict this position of this boundary and react and avoid crossing it. So this is example from Australia. It's a massive sandstone, and we had only one boundary above us at the top. And the goal of this well was to drill along the top, not far away from, not far than 1 meter away from the top. So it can be reached using only bulk resistivity, and we excluded from this BHA, we excluded periscope and replaced it by arc with bulk resistivity. And yeah, the separation help us to understand the boundary position and reach the goal. And at the end of the well, we checked the position of this boundary by crossing it. So here it's proof that our algorithm works correctly in this area.
So in this example, you're going to the top of the formation where you have a highly resistive oil zone versus a low resistivity shale above. It can be done in the other one where you have a thick sand full of oil and you're going to a contact. So you know,
problem with this approach that you need to have only one boundary in the distance of your tool investigation, because if you have another boundary, you cannot separate the signal between these two boundaries. So this method can be used only with one boundaries.
With one boundary. So if you have a nice thick sand and a thick oil zone, and you're trying to put a well near the oil water boundary, but you don't want to cross the contact, you could do it in this in that one as well. You could model where the contact is from the well.
Yeah, it's possible to do it with oil water contact, but you need to have like a sharp contrast between it. If you have some transition zone, probably you you will put the wrong parameters for the model, because what is the area you want to map? For instance, if you have oil bearing zone like 20 ohm meters and you have water 2 ohm meters, but you have transition zone, this resistivity like changing from 20 to 2 meters on the distance, like 2 meters of TVD. So you need to be sure about parameters you put in the inversion.
Understood.
And it's always the problem with deterministic, because it's highly dependent on user input, and you need to understand that you have put the correct parameters here. And this example with good contrast between shale and sandstone, it's possible because we have only one resistivity for shale, only one resistivity for oil bearing zone. But if we are speaking about some oil water contact, anyway, we have some transition zone, and we need to be sure that parameters is correct. Okay. Any question on deterministic conversion?
No, I don't think so. I think we're conscious of time. We only have about 9 minutes left. What else did you want to show, Daniel?
Yeah. And speaking about the cases when you have some lateral changes and you have fluids, we have vendor-independent resistivity stochastic inversion. So you can use this inversion to detect the fluid contacts and detect a few boundaries simultaneously. So in this example, you can see that we have top, which is indicated by blue color. We have our target zone in red, and at the end of the trajectory, in the end of the well, you can observe this pinch out. So by using stochastic inversion, you can map fluid contacts, you can map pinch outs, and you can detect more than one boundaries at the time. But because of all resistivity tools is different, and we need to implement, before running this inversion and resistivity, we need to implement these tools into StarSteer. So for now, we implemented more than 30 tools to StarSteer. It's almost all tools which currently using on the market. So it's all tools from Schlumberger, from Baker Hughes, from Halliburton, and few tools from small companies which can be used to for azimuthal resistivity modeling. Yeah, let's keep a target line. In StarSteer, we have reporting, so you can customize your PDF reports and print it directly from StarSteer. You can put any information here from StarSteer or third-party application. You just need to place it somewhere on the drive and to assign this weight to this file. And yeah, this is very easy to create and very customizable. We have PDF reports. And another way how we can another way how we can make reports is to use our cloud system. So we have a cloud. This cloud can be connected to any software. It can be ROGII software or third-party software. In ROGII, we have StarSteer as software for geosteering. We have forecast for completion. We have data manager to visualize data in time, and you can do some drilling analytics here. We have data manager visualization of the data and drill spot for data analytics and drilling data analytics, and Starlight, it's visualizator of your interpretation on the phone or on the web. I will show it later. And we have what is important for geosteering too. It's to have a data on time, in real time. And for these goals, we have a solo box. It's a data aggregator which can be set up on the ring and can aggregate all the data from the rig and stream it through our own server to cloud system. And from cloud system, you can get this data from to any software, and yeah, it's very seamless collaborative platform. Okay, let's show how we can see interpretation on the phone. So here I have let me open it again. Connect. Here I have my phone, and I open the app which mirror my phone. Let's wait while it'll update it to me. Okay. USB connection. I would like to connect my phone here. In just a second. Yeah, it's connecting. Yeah, here I have my phone, and on my phone, I can visualize the same interpretation I have on the desktop. So let me open this project. Here I have the same project. You see, it's Kazakhstan project. It's project from Kazakhstan. As a geosteering engineer, I set up this visualization, and I'm doing the well. I am changing the interpretation, but as operational geologist, I would like to see this interpretation on any devices at the same time. So here I have my phone. You can see that I'm moving it by my finger, and I can see tracks. I can see all data here. I can change my visualization, so I can visualize any logs I want, any data, any interpretation I want. I can see some details. I can understand how much length I'm in the zone. So here I have 70% coverage of zone, and I can measure some distance as well. So it's very powerful tool for operational geologists, because you don't need to open a project all the time. You just need to open an app and to see your current interpretation, which is doing by engineers. If I change some dips here, like this, I can see immediate response on my interpretation. Just a second. It will be updated. Yeah, you see? So it's all connected, and as operational geologist, I don't need to go somewhere to see my current interpretation. I don't need to ask geosteering engineer to send me file or send me image. I just need to open it up and see it at the same way as my engineers. Okay. Serge, how much time do we have? Only 2 minutes.
I think we're almost out of time. That was very good, Daniil. Any questions from anyone? We'll be posting this on our YouTube channel. We try to keep it to an hour. It is a lunch and learn, and you guys got to get back to work. We understand. But we definitely thank you, Daniel. You're always available. We can share your LinkedIn profile and access to you at any time.
Yes.
Okay. And also the team here at GGRE's, thank you very much to Banu, NG staff, for organizing this webinar on this lovely Valentine's Day. Happy Valentine's Day to all. Hey, what do you got? What was the last thing you wanted to show about what's
Yeah.
that?
It's just interesting things that probably you know about OpenGPT, ChatGPT, artificial intelligence algorithms. So we asked this AI how to improve geosteering workflow. The answers was here. So we discussed with you almost all of these points. So we have machine learning in StarSteer. We have a collaboration platform on the cloud. We have like high-tech technologies, and yeah, we have integration. We have everything.
Okay, that'd be great. That would be great to have their signature on it, the ChatGPT. So that's cool. It's taking the world by storm.
Yeah, now we can say that StarSteer is approved by ChatGPT.
Great. Well, thank you very much, Daniel. We'll bring it to a close. Thank you, everyone, for joining.